Assalamualaikum warahmatullahi wabarakatuh. My name is Syahid Al-Muhaizin bin Sulaiman. Today, I want to discuss about nozzle and diffuser. Nozzle. A nozzle is a device that increases the velocity of a fluid at the expense of pressure. As we can see, the size of the inlet is more bigger than the outlet. For diffuser is a device that increases the pressure of a fluid by slowing it down. Opposite from the nozzle, the size of the inlet for diffuser is smaller than the outlet of the diffuser. Both are commonly used in jet engines, rockets, spacecraft, and even garden hose. The cross-sectional area of a nozzle decreases in the flow direction for subsonic flows and increases for subsonic flows. The reverse is true for diffusers. Nozzle and diffuser are shaped so that they cause less change in fluid velocities and thus kinetic energies. This is the energy balance for a nozzle or diffuser. E dot in equal to E dot out. M dot times H1 plus V1 square over 2 equal to M dot times H2 plus V2 square over 2. Next, let's try an example of a nozzle. So, this question is about a water vapor enters a nozzle at 500 degrees Celsius and 600 kilopascal with a velocity of 15 meter per second. It leaves at 250 degrees Celsius and 300 kilopascal. During this process, heat is lost at a rate 30 kJ per second. For an inlet area of 0.07 meters square, determine the velocity and volumetric flow rate of the steam at the nozzle exit. To solve this question, first, we need to draw the nozzle and label it H2O because this question is about H2O. So from the question also, we can list all the information, that is T1 equal to 500 degrees Celsius, V1 equal to 600 kilopascal, V1 is equal to 15 meter per second, T2 is equal to 250 degrees Celsius, P2 equal to 300 kilopascal, Q dot is equal to negative 30 kJ per second. It is negative because the heat is lost, so we use negative. Next, A1 is equal to 0.07 meters square. We also know that there is no work, so W0 is equal to 0, and there is also no elevation. Potential energy is equal to 0. Next, we can use first law equation, that is Q dot minus W dot equal to M dot times H2 minus H1 plus V2 square minus V1 square over 2 plus G times Z2 minus Z1. Okay, from the information that we have list, we know that W dot is equal to 0 and the potential energy is also equal to 0, so we can cancel both of them and get new equation, that is Q dot equal to M dot times H2 minus H1 plus V2 square minus V1 square divided by 2. Next, at table A6 with the given T1, T2 and P1, P2, we can get the value of V1, that is 0.5920, H1 is 3483.4, V2 is 0.79645, and H2 is 2967.9. From that, we can now find the M dot, which is equal to 15 times 0.07 divided by 0.5920 equal to 1.774 kilogram per second. Next, after getting the value of M dot, we can now solve the first law equation to get the value of V2. And V2 is equal to 998.7 meter per second. Lastly, we can find the volumetric flow rate and equal to 1.41 meter cube per second. That's all from me. Thank you.
What is throttling process? A throttling process is defined as a process in which there is no change in enthalpy from state 1 to state 2, which means there's no work done. And the process is adiabatic, that the amount of heat transferred is equal to zero. As for throttle valve function, in general terms, the throttle valve must regulate the air mixture supply for the combustion engine. Depending on the engine concept, this serves different purposes. In the case of petrol engines, speed and power output are regulated by means of fresh air or mixture dosing. Meanwhile, in modern diesel cars, throttling the amount of intake air facilitates precaution control for exhaust gas recirculation and stops the engine from shaking when the ignition is switched off. Presumed from previous slide, the throttle valve is installed in the intake air system of the combustion engine. The opening angle of the valve determines how much fresh air or fuel mixture flows into the cylinders. For instance, carburetor engines. For newer vehicles, there are various principles of operation. For example, electronic throttle actuators. With electronic throttle actuators, there is no direct connection to the accelerator pedal. The driver's desired load is captured by an electromotive throttle actuator. Then, the engine management permanently matches the signal to all other available data from the engine sensors, using the information obtained to calculate the optimum throttle positions for the prevailing situation. The electronic throttle actuator is controlled exclusively using the control signal from the engine management and with the assistance of a servo motor. Let us see some throttling valve related problem. Here it's stated that steam enters a well-insulated throttling valve at a mass flow rate of 15 kg per minute with an initial pressure of 550 kPa and initial temperature at 200 degrees Celsius and exists at a temperature of 200 kPa. What is the temperature of the steam upon exiting the valve? First step is to obtain specific enthalpy of steam at initial pressure 550 kPa and initial temperature 200 degrees Celsius from superheated water tables. There you'll get 2853.2 kJ per kilogram. In throttling process, enthalpy remains constant during the process, hence, enthalphy of steam before and after leaving the throttling valve remains same, which is H1 equals to H2 equals to 2853.2 kJ per kilogram. Finally, find the exit temperature of the steam at the exit pressure 200 kPa and enthalpy 2853.2 kJ per kilogram from superheated water tables. Then you'll get the temperature of steam leaving the valve is 191.387 degrees Celsius.
Hi, Assalamualaikum. My name is Ahmad Najmuddin bin Zamri. My method number is CD190327. Okay, today I will present to you about compressor. Okay, what is compressor? Compressor is the device which is used to compress the fluid and increase its pressure. Okay, compressor has two types. In the first type, there are also two types. Okay, the first type is a positive displacement machine that has high pressure ratio and low mass flow rate. Okay, for the first type, rotating, there are screw compressor. The second one is cold compressor, and the last one is rod blower. Okay, for the screw compressor, it's commonly used to replace piston compressor where large volume of high pressure air are needed, either for the large industrial applications such as chiller or to operate high power air tools such as jackhammer and impact wrench. Okay, for the next one is screw compressor. The screw compressor is a specially designed the compressor that work in a circular motion as opposed to up and down piston action. Okay, next one is rod blower are used to generate constant airflow that are independent of discharge pressure conditions. Fluid blower applications are limited to low and medium pressure and vacuum process and can be used to provide small to large air fluids. A fluid type alternating reciprocating compressor. A reciprocating compressor is a positive displacement machine that uses a piston to compress air gas and deliver it at high pressure. They are often some of the most critical and expensive systems at a production facility and deserve a special attention. Okay, for the second type, a turbo compressor that has low pressure ratio and high mass flow rate. Okay, for the first one is a centrifugal compressor are used in a wide variety of applications in chemical plants, refineries, onshore and offshore gas lift and gas injection application, gas gathering, and in the transmission and storage of natural gas. Okay, the next one is axial flow compressor, comprised of multiple stages of rotating and stationary blades or rotor or stator through which are in drawn in parallel to the axis of rotation and incrementally compressed as it passes through each stage. Okay, for the next one is mixed flow compressor or known as diagonal compressor. A mixed flow compressor combines axial and radial components to produce a diagonal airflow compressor stage. Okay, let's go to calculating some question. Okay, for the question, air at 100 kilopascal and 280 kilo in is compressed steadily to 600 kilopascal and 400 K. The mass flow rate of the air is 0.02 kg per second and heat loss of 16 kilojoules per kg occur during the process. Assuming the changes in the kinetic and potential energy are negligible, determine the necessary power input to the compressor. Okay, this is the solution. Okay, E in equal to E out, W in equal to M times H1 equal to Q out plus M times H1. When we simplify, we will get W in equal to M times Q out plus M times H2 minus H1. Okay, H1 is equal to H at 280 kilos and H2 is equal to H at 400 kilos. Okay, we can see the data from table A70. You can see from the the red line that I have tick 200k. The H will be 280.13 and 400k will be 498. Okay, after we get both of H, we will put into our equation. We have got M and Q out. After we put all the W in will be 2.74 kilowatts. Okay, that's all for me. Thank you.
So my name is Wan Muhammad Shakir bin Wan Muhammad Anapi. My metric number is AD190016. So today I am going to present about turbine. So turbine actually is the device in which fluid expands during the expansion would be done by the fluid to drive. For example, in electric generation. In this case, power output occurs. So that compressor is the device which is used to compress the fluid and increase its pressure. That means power input is required. And also they are classified as such because engineers are simply technologies that take an input and generate an output. For example, a simple turbine is composed of a series of blades. They're usually using steel, which is one of the most common material used, and make the fluid allow to enter the turbine and pushing the blades so that the blade will spin and eject the fluid, which now has less energy it did than when it entered the turbine. So some of the energy is captured by turbine and used. So the first law of thermodynamics is like I state below. So after we simplify the expression, so we will get Q plus W plus H in and H out equal to 0. So that turbine driven generators. Actually, most of US and world electricity generation is from electric power plants that use a turbine to drive electricity generator. In a turbine generator, a moving fluid, water, steam, combustion gases, or air pushes a series of blades mounted on the rotor shaft. The force of the fluid on the blade spins will rotate the rotor shaft of a generator, so that the generator in turn converts the kinetic energy of the rotor to the electrical energy. So figure below is shown that from kinetic energy sources will convert to the rotor, will directly transfer to rotor, and rotor shaft will spin and will directly convert to electricity to consumer, which is our customer that also use electricity. So as we know that different type of turbines include steam turbines, combustion gas turbines, hydroelectric turbines, and wind turbines. So for example, solar photovoltaic cells, actually they convert sunlight directly into electricity. So they are commonly used to power device as small as wristwatch and can be connected together in panels that are connected together in arrays to power individual homes or form large power plants. PV power plants are now one of the fastest growing sources of electricity generation around the world. So next, the second part that commonly used in the world. So internal combustion engines such as diesel engines also used around the world for electricity generation, including in many remote villages in Alaska. So as we see on the right top, the diesel engine power plant actually have fuel tank which directly sent to engine and generator, and there will a turbine blade and will convert to the cooling tower, which has air in. So they are also widely used for mobile power supply at construction sites and for emergency, or also can use for backup power supply for buildings and power plants. So diesel engine generators can use a variety of fuels, including petroleum, diesel, biomass-based liquid fuels, and biogas, natural gas, and propane. So that is electricity. So as we can see on the right top of the picture, generally the construction of hydroelectric turbines is the same. So a row of blades is fitted to some rotating shaft or plate, and then water is then passed through the turbine over the blades, which is cause the inner shaft to rotate. So this rotational motion will transfer to a generator where electricity is generated. So there are variety of different types of turbine that are best used in different situations. Each type of turbine is created to provide maximum output for the situation which we can use it. So there are many factors that must be investigated to determine which turbine should be used, so that it can output and input also can be the best power that supplied to consumer. So these are factors include hydraulic head, hydroelectric discharge, and the cost. So these turbines are essential in the area of hydropower, which is the process of obtaining power from water. So that's it from me. Thank you.
Hi everyone, today I would like to explain an example based on heat exchanger. This is the example of question. If you see, the water is heated from 40 degrees Celsius to 70 degrees Celsius by an oil entering at 110 degrees Celsius in a counterflow heat exchanger. If overall heat transfer coefficient is 350, calculate the surface area required. Okay, this is the question. The given detail based on two type of fluid, which cold fluid represent water and hot fluid represent oil. Okay, the mass of the water is 1.4, which is given in the question, and the specific heat capacity also is given, which is 1.187. The heat transfer, which is 40 degrees Celsius to 70 degrees Celsius, and the mass of the oil is 2, and specific capacity of the oil is 1.9, which is given the question, and the degree, the temperature given is 110 degrees Celsius, and the heat transfer coefficient is 350. The question is how much is the surface area. So let's move on to the solution. First of all, draw a diagram. Okay, then before move on to the diagram, why this process called as counterflow heat exchanger? Because if you see, the hot fluid, which is oil, is moving from left to right, while cold fluid, which is water, moving from right to left, which is in the opposite direction. So this is called, and this is known as counterflow heat exchanger. This is temperature distribution graph, where the y-axis is represent the temperature and x-axis represent the length. Okay, if you see, the hot fluid is reducing and cold fluid is increasing. So this means the hot fluid is losing the heat and the cold fluid is gaining the heat. So the difference between these both temperature will be the theta 1, and difference between these both temperature will be the temperature theta 2. Okay, let's move on to the heat transfer formula, which is Q equal to UA LMTD, which is, this is the first equation. Okay, another thing, heat loss by hot fluid is equal to the heat gain by cold fluid. So the formula is Q equal to Mn Cpn Tni minus Tno is equal to Mc Cpc Tco minus Tci. So since if you saw here, the value of Tno is missing, so to find the Tno value, you need to identify the value of the Q first. So you will take this formula and insert every value in this formula. So we can get 175.85 times 10 power of 3 watt. Okay, then to identify the Tno, substitute the value into the Q and identify the value. So the answer will be 63.72 degrees Celsius. So this is the value of Tno. Next, to identify this both theta T1 with theta T2, for theta T1, Tni minus Tco, which is 110 minus 70, which is equal to 40 degrees Celsius, and theta T2 is equal to Tno minus Tci, which is 63.72 minus 40, which is 23. Okay, this is LMDT of the counterflow heat exchanger. The formula of LMDT, which is theta T1 minus theta T2 over ln theta T1 over theta T2. Then substitute all the value, you will get 31.15 degrees Celsius. And finally, you have to put all the values in the equation, which is state before. Then you substitute all the value, which is Q value, U value, ln Td value. Then you can get the surface area, which is 16.13 meters square. So the answer is given, which is 16.13 meters square. That's all from me. Thank you.